Sorry I couldn't be with you today, but I'm going to guide you through your very fun activity. And if you do it just right, you might win a candy when I get back. So in order to get prepared, what you are going to need is to log on to the course Moodle, and under Unit 3 you'll find a link that says quadratic relations. You're going to click on that and we'll be using that website a little bit later on in the activity. You will also need a sheet of paper. You can take it from your binder or you can go up and get a piece of scrap paper from my desk. You will also need a pair of scissors that you can get from my desk. So pause the video, go get logged on and get those things, and then come back. Pause now. Alright, welcome back. I hope you have all of the things that you need to get. What we're going to be doing is determining how perfect your jawline is to a parabola. So we will be examining things in real life that are parabolic in shape. One thing would be your teeth. Dentists describe the arrangement of human teeth as a parabolic dental arcade. So this is what you're going to do. Step 1, you're going to take a sheet of paper. You're going to bite down on it at the corner. So when you do that, this is what it's going to look like. Right there, there is the paper, there's where I bit, and there is the sort of parabola shape that my teeth made. So that's step 1. Step 2, what you're now going to do is to cut out the parabolic shape that your teeth formed using the scissors. So when you use the scissors, you're going to cut right on the edge as best as you can. Right along there. So just do your best to cut along the edge of that parabola. So pause the video and cut out your dental parabola, please. Pause it now. Alright, hope you did a good job cutting out that parabola. Here's the next thing you're going to do. You are going to place your dental parabola on your grid so that the space where is in between your two front teeth, which are called your incisors, are going to go right at the origin right there. And then your parabola is going to be looking like this. So I'll show you what that means. So you can see right here, in between your two front teeth is the vertex of your parabola, and it's going to be placed at the origin. Then you're going to take a pencil and trace along the outside of your cutout parabola. Then when you remove that parabola, you're going to get the shape on your grid that looks like this. So hopefully that is what it looks like. So take a few minutes and make sure that you have traced the outside and you get something like this. So pause the tape or the video now, do that, and then come back to the video when you're done. Alright, so welcome back. The next step we're going to take now is to locate 7 coordinates on your teeth parabola. One will be the vertex at the origin, and then you're going to find 3 points on the left and 3 points on the right, and you're going to do your best to estimate what those coordinates are. You won't know for sure, but you're going to estimate what the coordinates are, and you're going to record them in this table. So I will show you what that looks like. So 1 point there on my vertex. I just decided to pick points at -2, -4, 6 on the left, 2, 4, 6 on the right, and then I just did my best to estimate what the y coordinates would be. So that would be -2.5, -4 about 1.9, and -6 and about 3.75. So I've written those coordinates there. And on the right, 2 and about 0.3, 4 and about 1.5, 6, and approximately y value of 4. So pause the video, take a minute, locate your 7 points, and write them in the table just like this, with the x coordinate in the first column and the y coordinate in the second column. When you're finished that, return to the video. Alright, welcome back. Hope you had an easy enough time finding those 7 points. What we're going to do now is something called quadratic regression. And quadratic regression is basically what you do is we are going to take a look at the relationship between the x variable and the y variable, and we're going to try to make the equation of that parabola. So this is now where you have to go to that quadratic regression website that was on the Moodle, and hopefully you already got to that website. If not, pause the video, go to that website. That's the instructions are on the previous page, and open that up. Alright, so I've got a split screen going on here, so the writing is a little bit smaller, but this is what the website should look like right here, the polynomial regression data fit. And I want you to scroll all the way down here to where it says data entry area. So the instructions say you will enter your data in the data entry area. There will already be points in the area when you first open that. All you're going to do is just delete them. So just highlight them all and delete. And when you enter them, what you want to do is make sure that each point is on its own line. You're going to press enter between each point, that you separate the x and the y coordinate with a space, not a comma, and you do not put brackets around your point. So in the data entry area, the first point had an x value of -6, and then a space, and its y value was 3.75. Press enter. The next point had an x value of -4, space, and the y value was 1.9. So pause the video, take a couple of seconds, and enter in all 7 points. So pause the video now. Okay, so you've entered in all 7 of your points right there. And now if you scroll down, you will see what is called the parabola of best fit. Similar to a line of best fit in grade 9, it's a parabola that will go through as many of your points as possible. It just shows that since it's not going through all the points, that my teeth do not land in a nice perfect parabola. But it will try to go through as many points as possible, just like a line of best fit would. So your graph shows up in the chart area. So does your scatter plot look like the one that you drew? So there is my parabola. Okay, the scatter plot in parabola best fit should be similar to what this looks like. Okay, so what you're going to do is to sketch your parabola best fit on your graph. This will be a little bit challenging to do, but this line here that we traced around our teeth, that is actually not the parabola. That is just the tracing that went around our teeth. So you can see the parabola missed some of the points. So we're going to try to draw what this blue line looks like here. So you're going to draw that on your grid that was on page 6. Mine's here. And it'll be a little bit challenging, but so it's going to come on this side of the first point, and then it's going to come down like this, and then it's going to be above that point and above that point. And I didn't do the best job on that side, so I can erase it and make it look a little bit better. But what you're just trying to show here is the difference between what the points actually look like if they were joined and what the parabola would look like if it was a perfect parabola. So it's a bit of a hard thing to do, but I just really want you to see that the lining up of your points is not going to be an exact parabola. All right, so back to the instructions. It says to scroll down to the results area, which is down here. All we need out of here is to look for the r squared value. So that is r squared because that's the right there, that's the exponent symbol. So the r squared value is right here, right there, and it is called the coefficient of determination, and it indicates how closely your data resembles a true parabola. So you are going to write down what your r squared value is and round it to 4 decimal places. So mine was 0.9918. And the question is, how well do you think your teeth resemble a parabola? Fully justify your answer. So one thing that you should know is that the highest this r squared value can go is 1. If your r squared is equal to 1, that means that all of your points were on the parabola and your points made a perfect parabola. So pause the video, take a minute to answer how well do you think your teeth resemble an actual parabola. So pause and then come back to the video. Okay, 2 more things and we are done the activity. The first thing is we are going to write down the equation of our parabola. Equations of parabolas are in this form right here. Y equals ax squared plus bx plus c. The first term is called the quadratic term because that's the one that has the exponent of 2. The bx is called the linear term because it has an exponent of 1. And the c is called the constant. So what you have to do is substitute the values of a, b, and c into the equation. The values of a, b, and c are given right here in the website. The only issue is, and I'm not sure how familiar you are with scientific notation, this e negative 002 means that the decimal place here, so the number isn't actually negative 2.38, it means that the decimal place, which is right here, has to be moved to the left 2 spaces. This one here, the decimal has to be moved to the left 3 spaces, and this one here, the decimal has to be moved to the left 1 space. So my equation, instead of it being negative 2.38, it would be negative 0.0238. Sorry, I didn't leave a lot of room there for the number. This one here, decimal has to move 3 places to the left, so it would be negative 0.00446. And this one here, the decimal has to move 1 place to the left, so that would be 0.108, and that 1 will round up to a 2. And that's how you get the equation of your parabola. One last thing to do before we run out of time. I want you to go to Google Docs, and I have shared a document with you called Parabolic Dental Arcade. I want you to open it up, and beside your name, write down the value of your coefficient of determination, which was the r square value rounded to 4 decimal places. So I will be checking that tonight to make sure that you've done the activity. Thank you for watching, and I hope you had fun.